Hi there, welcome back to Using X as a Number and continue our algebra journey. And if you remember, we have been using X or N as a number to help solve puzzles and problems. And isn't algebra a fun way of solving practical problems and puzzles? So right at the moment, what we're going to try and do is to say, well, if we're going to go on to bigger, more practical problems, then we're going to need to be able to do things with X that we do with other numbers. What are some of those things? Well, we have done addition with numbers, and we also do subtraction, and we've done some of that with X already. What else do we do? Do you remember? With ordinary numbers, well, we do multiplication. We've done a bit of that with X also. We also do division. So I guess if we're going to be using X in algebra to solve problems, we're going to need to be able to do all those things with X, or with any other letter that was standing for that missing number. We have used N as well. So any of those letters are called pronumerals. So X is a pronumeral, and a pronumeral means it is a letter pro standing for a number. It's got a Latin origin, and so what we're going to try and do now is do some practice. Can we do with X all the things that we usually do with numbers? So let's come down here and try and do some addition and subtraction with X. So you might have a look at this problem as I write it. 3x plus X, take 2x plus 5x. I wonder what that would come to. And then 7x, take X, plus 2x, take 9x. So let's have a look at those now. So we've got 3x plus X is 4x, take 2x is 2x, plus 5x is 7x. Oh, sorry, I think it's like counting cats or dogs or something. We've got 3 cats, plus 1 cat is 4 cats, take 2 cats is 2 cats, plus 5 cats is 7 cats. So let's try it with the next one now. We've got 7x, take x is 6x, plus 2x is 8x, take 9x. Better come over here, do a bit of revision on our number line. So this is the positive direction of the number line going this way. So we said we had 7x, take x is 6x, plus 2x is 8x. So let's represent that here. 1, 2, 3, 4, 5, 6, 7, 8. We don't know the actual value of x, but we could let this position here on some scale be 8x. And now we're taking away 9x. Now the negative side of the number line is going this way, so we're actually going to take away 9x. So we go 1, 2, 3, 4, 5, 6, 7, 8. That'd be neg 8x. We've got to go neg 9x. So this spot in here would be neg 1x. 1x worth to the left of 0, if you like. So we'll write our answer as neg x. Remember, we don't usually put the neg 1 in front of x. How did you go with that? Let's mix it up a bit. Have a look at some more problems here. 3x plus x, take 2, plus 4, take 5x, plus 1. Can you see what I'm doing there? Doing something slightly different. Then 3 take 4x, plus 1, plus 5x, plus 2x, take 5. So mixing them up here now, there are some letters or pronumeral terms, things with x's in them, and then there are some numbers as well. Let's go through and say, well, what can we do here? Well, if x in any problem always means the same value, then let's collect up our x's. So that's 3x plus x is 4x. Take 5x. So here we'll go again. 4x is over here somewhere, and then take 5x. So again it's going to be over here at neg 1x. So answer in x land is neg x. Now our numbers can't be linked with x because we don't know the value of x, but we do know the value of these numbers. Neg 2 plus 4 will be positive 2, plus 1 is positive 3. I'll add 3 here. Let's have a look at the other one now. Because the number comes first, maybe let's start there. So we've got 3. Now we can't add 3 and 4x or take them away because we don't know how big x is. So we'll have to leave that one and go to the next number. 3 plus 1 is 4, and then 4 take 5 is neg 1. Let's now look at our x terms. Neg 4x plus 5x is 1x, plus 2x is plus 3x. And of course what we usually do there is to put the x term first. 3x take 1 then would be our answer. So you can see there's some positive and negative number work involved here, and you might like to revise it or check it out each time by drawing a little number line. This isn't a bad method of handling that. Okay, so what do you think? Distance subtraction okay? Well, we'll practice again in a minute, but let's come down here and actually do some multiplying now. So what about 3x times 2, or maybe 3x times neg 2, something like that. So here, how do we read this? Timesing means we're doubling it. So if we had 3x and we doubled it, be 2 lots of 3, that would be 6x. And here, neg 2 times 3x, neg 2 times 3 is neg 6x. What does it mean, that negative business? Let's have a look. What it means is here, if we had our 0 and we have 3x over here, now if we doubled it, we would keep going out in this direction to 6x. That's our first problem over there. But if we multiply it by neg 2, we're changing its direction. So instead of going positively, we want to go from 0 to the left. So that's going to be down here at neg 6x. But instead of going two lots this way to 3x, we're going to go all down to the left here, 2 lots of 3x, but the negative sign is saying please move to the left. They might have to revise some of that because that really is more about positive and negative numbers, not about x itself. So what about an x times an x? Oh, not sure about that one. Let's look at 2 times 2. We would call that 2 squared, which would be equal to 4. So let's do the same with x. X times x would be x squared, but we can't put any more because we don't know what x is, but we can go that far. X times x is x squared. What about 2x times 3x? Now, when we're working with numbers and x as well, then we'll have to keep the numbers together. 2 by 3 is 6, and then x by x is x squared. What do you think about that? Well, we'll do some practice later on, just see if you can see what we're trying to do here. We're trying to do the same sorts of operations with x as what we would do with any other number. Let's go down to doing some division here. What about x divided by 2 plus x divided by 3, or even I suppose something more difficult. What could we try? Something like 2 over x plus 3 over 2x. Ooh, this looks like, what does this look like? This looks like fractions to me. So I think we probably need to do a bit of revision of addition and subtraction of fractions with ordinary numbers before we can tackle these. So let's have a look at a fraction problem back from earlier years. Let's say 3/4 plus a half. What on earth does that mean? Well, here we can't add them, can we? Because this is 3 lots of a quarter. So as it stands at the moment, we can't add them. And this is 1 lot of a half, if you like. So thinking about that, it's like saying trying to add 3 cats and 1 dog. Let's see if we can make them common units. So drawing this here now, 3/4. Well, let's roughly say this is 3/4, 4/4 in a whole. And over here, what have we got? We've got 1/2, which is that. Now we need to try to add this up, so we need to try and make them into the same units. So let's try and do that now. So to do that, well, this is all in quarters over here. So can we, and this is in quarters, can we actually make this into quarters? Well, yeah, there would be, here there are actually 3/4, and if we divide the half up, we have 2/4. Well, that's the idea. So this is now 3/4 plus a half has been changed to 2/4. So if we come down now, we would say this is okay because they're both quarters, they've both got the same bottom line or denominator. So this is 5/4. Again, 3 cats plus 2 cats is 5 cats. But our challenge, of course, is to be able to change our fractions to the same units. So how would you do this without all the diagrams? I think you might remember now. What we're going to try and do is say, well, 3/4 is okay, but if we had a half, how would we work out the number of quarters there? Well, we want 4 in the bottom line, so we actually want to double that to make a 4 there, but you can't change the meaning of the fraction, so we must do the same to the top line. So what effectively are we doing there? We're actually multiplying by 1, so we're not changing the meaning of the fraction. But look at what happens now. That's 3/4 plus 2 1s are 2, 2 2s are 4. That is a good way, without a diagram, of changing them to the same units, and therefore we have that answer. Okay, so have a look at that as a way in which we work with fractions in ordinary number land, because we need to be able to do it with x's. So just have a look at that and make sure you're happy with that. Okay, well, what about another one then? What about 3/4 plus 2/3? So let's do one more diagram, then we'll stop and simply look at the operations. But again, the 3/4 was over here, which looked like this roughly. Now 2/3, of course, a bit harder to draw, will come in here like this, and 2/3 maybe looks like this. So now we have to change those to the same sorts of units. So here, I think you might remember from prep school, we look at the product of these two denominators. So 4 times 3 is 12. So if we could convert them all into twelfths, then we would be able to perhaps add them up, because at the moment we've got 3 lots of a quarter and 2 lots of a third. So let's change them all to a smaller unit and add them up. Let's try twelfths. Okay, so twelfths now. Now there are 12 twelfths in a whole. So in a quarter there are 3 twelfths. So if we're dividing this up, there are 3 twelfths. Okay, so how many twelfths are there in 3/4? Let's count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3/4 is 9 twelfths. Plus now over here 2/3. Now if there are 12 twelfths in a whole, in a third has 4 twelfths in it. 4 twelfths. So here, let's divide this up into twelfths. There are 4 of them in there and 4 in here. So in 2/3 we've got 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 twelfths in 2/3. And now we can add them, can't we? We can say we've got 9 cats plus 8 cats, 17 cats, or 17 twelfths. So that's the idea. Now let's try and summarise it all without a diagram here. So let's come down and just say, what would we do to change 3/4 to twelfths? Well, we want a 12 on the bottom line here, so there are 3 twelfths in each quarter. So here multiplying top and bottom by 3, and over here with 2/3 we'll multiply top and bottom by 4. Okay, so that we've got 3 by 3 is 9 twelfths, plus 2 by 4 is 8 twelfths. Okay, so we've been able to actually change both of the fraction into those common units without a diagram. So this operation here, multiplying top and bottom by the same number so that you leave the fraction unchanged, is the important point to take away from this, because we've got to do this in Xland shortly. So we have been able to change them to the same. So now we've got 17 twelfths, which checks as before. So let's take away the idea here from this. Let's go away into Xland again with the idea that you're going to multiply top and bottom, or numerator and denominator, top and bottom by the same number, and we usually, in this sort of problem here, it's going to be the common, what's called the common denominator, or common bottom line. And we get that by using the product of the two bottom lines. So if it's 3/4 and 2/3, our common denominator in this case is going to be 12. Alright, so just study that for the minute and see what you think. Well, what about our fractions with x in them now? What do you think about that? Let's try those that we've mentioned before. Let's go x over 2 plus x over 3. Alright, well, we know x is just a number, so what are we going to do? Well, what's our common denominator? 2 by 3 is 6. So let's make both bottom lines 6 by multiplying top and bottom by 3 over here and top and bottom by 2 over here. So what that means now, our problem becomes 3 times x over 3 times 2, which is 6, plus 2 times x over same bottom line, 3 times 2 is 6. So you can see how this common denominator is operating here, because we now have 3x cats plus 2x cats, if you like. So we've got 5x cats, or 5x over 6. And that's as far as we can go, because we don't know the value of x. So quite interesting to do it in x land, isn't it? The important thing is to say, well, do you know why it works with ordinary numbers? And then to say, well, x is just a number, so it will work for it as well. What if x is in the bottom line, as I mentioned to you before? So 2 over x plus 3 over 2x. Now, this is interesting. It's important for you to know how it all works here, so that we can do something with these. The interesting thing here is this is x and this is 2x. So if you want them both to be the same, can you spot a shortcut? If you multiplied top and bottom by 2 here, let's look at it, that would produce 4 over 2x. And there's no need to change this dude. It's already over 2x. So we're going to say this is 7 over 2x. Are you happy yet with treating x as just an ordinary number? So have a look now at what we're doing here. Remember, we're trying to make the same denominator for each of the fractions. So make a common denominator, because the idea is then you can add up units that are the same. Make a common denominator. Okay, so that's what we're trying to do there. Well, what about this one then? 3 over 4x plus 2 over 3x. Let's check them out. They've both got an x, but different numbers of x. So let's fix that up. 4 and 3 have a common denominator of 12. So if we multiply this one by 3 over 3 and this one by 4 over 4, we would have 9 over 12x plus here 8 over 12x. It works, doesn't it? The idea of changing both fractions, the same sort of units, the same denominator. So here we've got 9 over 12x plus 8 over 12x. That's the same as 17 over 12x. The important thing is to say, well, x is just another number and we're trying to make a common denominator so that we can add things up. Alright, so just keep thinking. Don't worry about x, it's just another friendly number in there, and we need to be able to do all sorts of things with it. Okay, want to do some practice. You might like to pause the presentation now and have a go at these addition and subtractions. So I'd like you to do that. Pause the presentation now and go through these 4 problems, just building up your skills. I've helped you a little bit here because I've reminded you that x is special and different from other numbers by putting it all in red. So that will help you identify which ones can be collected up together. Later on, of course, we won't be doing that, but just for the moment that might help you. So I'd like you to pause the presentation now. Alright, here we are back again. So let's see what we've got here. We've got 3x plus x is 4x. Take 2x is 2x plus 5x is 7x. How did you go? Now we have 7x take 1x is 6x, plus 2x is 8x, take 9x is negative 1x, or we write, remember, just negative x. Then 3x plus 1x is 4x. No x's on these two, so we'll move on. 4x, take 5x is negative x. And then we've got neg 2 plus 4 is positive 2, plus 1, positive 3. Do you need to revise, work on the number line here? Negative 2, so we're coming down here. Negative 2 plus 4 brings us up to positive 2, plus another 1 is positive 3. Might have to revise that perhaps. Let's look at the next one. Well, it's got a number in the beginning, so let's start with that. 3, when's the next number? Plus 1 is 4, take 5 is negative 1, and then we've got neg 4x plus 5x is 1x, plus 2x is 3x. Alright, maybe again work on the number line, do you think, with that x? Don't know, let's have a look. We start off with neg 4x, so it's down here on the negative side of 0, neg 4x, and then we add 5x, and that's going to end up over here at 1x, positive side, and then we're going to add 2 more x, so this is going to be positive 3x. So I'd encourage you to actually use a number line if you're not sure of that old stuff with directed numbers. Okay, we'll have a look at that and think about them. How about some multiplications now? So we have 3x times 2x will be 6x, and 3x times negative 2, remember, is negative 6x. X times x is x squared. 2x times 3x, 2 times 3 is 6. X by x is x squared, just like the ones from before. So just remembering those now. So a simple idea here is, of course, it's really keeping the numbers together, the ordinary known numbers together, and the x terms together. Okay, so keeping that in mind in our multiplications like that. What about some interesting combinations of some additions and some subtractions there? Let's try and look at these now. Now we need to remember BEDMAS here, where we need to do the multiplications first. So let's pick those out. So here we have 2x times 3x, so we'll rewrite this as 6x squared, so we're going to do the multiplications first. Then there's plus 7x, take 5x. Now there's another multiplication here, x times x, so that's x squared. Let's now simplify that a bit. We have 6x squared plus x squared is 7x squared, and then 7x take 5x is plus 2x. Can you go any further? No, because you've got 7 lots of x squared, which will be a different number from 2 lots of x. Remembering x is some unknown number, so you've got 2 lots of that, and over here you've got 7 lots of the square of that, so that will be a different number, so we can't actually add those up. Let's have a look at this second one, and again BEDMAS, as with numbers, is going to work with x's as well. You need to do all the multiplications first. So here they are here. So let's go through. We'll leave 8x out the front there, and then take x times 2x is 2x squared. Then we're down to plus 3x. Now we have 4x times 2x is 8x squared. Remember numbers together here. 4 by 2 and x by x. So we've done the multiplications. Let's now go through and add up the like terms that are like each other. So there's an 8x and a 3x. So we could call that 11x. And then there's neg 2x squared plus 8x squared is plus 6x squared. Okay, so again, we can't collect up this term and this term because there are 11 lots of the ordinary value of x and 6 lots of the square of x, which would be a different value. So that's certainly worth thinking about those combos there. Now, what about some divisions, some work with some fractions with x in them? Do you want to pause the presentation and have a go at these yourself, remembering what we're trying to do here is to always find a common denominator, the same bottom line. We want to do that in the shortest way possible. So you might just pause the presentation now and see if you can work with these fractions using the basic idea of making the denominator the same. Alright, well, let's have a look now and see what you came up with. So here we have x over 4 and x over 3. Well, we've seen this sort of one before, so the common denominator would be 4 by 3 or 12. So let's change both denominators to 12ths. So over here, to change 4, have to multiply by 3. I must keep the meaning of the fraction the same, so I'll multiply the top by 3. Then in the same sort of way over here, I want to make a 3 into a 12, so I'll times by 4, but I have to do the same to the top line. So what have we got now? We have 3x over 12, and then plus here x times 4, or 4x over 12. So that's worked out nicely for us. That's 3x plus 4x is 7x over 12. What about this next one now? Again, you might pause the presentation at any time and try and stay ahead. So let's have a look now. We have two denominators, x and 2x. Now, what is the simplest common denominator there? Well, it would be just 2x. So over here, if we multiply this x by 2, we've got to do the same to the top line, then that would be enough. Because let's have a look. 2 by 2 is 4 over 2x, and that one step has done it for us. That one step has given us the common denominator. So let's now look at what we have here. They're both lots of 2x in the bottom line. So here it's 4 plus 3 is 7 over 2x. So always need to look at trying to find that shortcut. Let's have a look at the bottom line here now. Is 2x and the other one's 3x. So we're going to have to use the common denominator idea here again. 2 times 3 is 6. So if we keep those numbers, or get those numbers both in lots of 6, the x's are okay, they're the same, just that number in front. So what do we need to multiply over here by? it's a 3 to get a 6 here, so multiply top line by 3 as well. And over on this side we have a 3x, we want to make that into 6x, so this one will multiply top and bottom by 2. Now let's do that and have a look. So this would be 3 by 3 would be 9 over 3 by 2x is 6x. Then take, I didn't mention that, did I? Do you remember the addition and subtraction of fractions has the same process, just with a different sign in between. So here it's 4 by 2 is 8 over 3x by 2 is 6x. So now we have all over 6x, 9 take 8 is 1 over 6x. So have a look at those, because they are stepping us up a little bit in Xland, in working with X. We should be getting pretty confident now that we can do anything we need with X. So study those and make sure. Can I leave you with these problems? Practicing working with X as a number. Now I've been a bit unkind. I've not highlighted the X in red here, but what I'd like you to do is to, in your own time now, have a go at solving these little expressions, or simplifying them really, and seeing how you go. And you might need to go back over the presentation and just check that you're happy with those. And then we'll come back and start there in the next part and see what equations we can now do using these skills. So I'll catch you then.